Assalamualaikum warahmatullahi wabarakatuh. My name is AIMAN FIKRIE bin SHAFIE. My metric number is DE30401. Today I'm going to present for the activity number 1, which is the basic operation of the SCR or silicon control rectifier or transistor. Okay, for the lab exercise 2, silicon control rectifier. So for this activity, we need to construct the circuit as shown in here in the lab sheet in the multisim. Okay, and the component that we need is DC power supply, 3 switches, 1 resistive load, SCR or in the other name is transistor, and the lamp as the indicator on how the SCR work. Okay, so for this activity we have 2 tables to fill in, which is the first table. We only include switch number 1 and switch gate, and for the table number 2 we added a new switch which is the S2 here, parallel with the transistor or SCR. Okay, for the table number 1, the condition for the 2 switches, which is the S1 and SD, is open, and then we run the simulation. We need to know what is the status of the lamp. So for the two switches which is open, there is no the lamp is not on because there is no current flow here. For the second operation, we need to close the S1 but open SD. Therefore, the lamp is still not on because the SCR need switch gate or to supply the current in order to make sure the circuit is complete. That's why the lamp status is off. For the next operation, we need to close the SD and close S1. So as we can see here, the lamp is on because the switch gate supply the current to the transistor, and the current flow through the lamp, and the lamp is on. For the next operation is we open this switch gate but still close the switch number 1. The lamp is still on because the SCR is supplied with current. Therefore, if we turn off the switch or open the switch, it still can flow. The current still flow and the lamp is still on. But for the last condition, the last operation, if we open the S1 switch, therefore the lamp status is off because we cut off the supply. That's it for the table number 1. For the table number 2, we added a new switch which is the S2 here. We need to know whether this S2 bring effect to the circuit. Okay, for the first condition or operation, all 3 switches are open. Therefore, the lamp is off because there is no current flow. For the second operation, we need to close S1 and the other 2 switches is open. The lamp is still off because there is no current flow here because the switch gate need because the SCR need switch gate to supply the current. The third operation is we need to close switch gate, switch 1, but the open switch 2. Therefore, the lamp is turned on, as I stated earlier. And for the fourth operation, we need to close S1, open SG, switch gate, and close S2. For this operation, the lamp is still on because the current bypass through the switch and flow through the lamp. Therefore, this is not working. So the lamp is turned on. But if we close S1 and open S2, the lamp is turned off because because there is no current flow because the SCR is not supplied with the current from the switch gate. I think that's all for the activity number 1. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul HAKIMAN bin Abdullah, and now I want to run a simulation for activity 2, which is SCR power switch with DC input. So after complete the circuit as shown, first we run the circuit, and for this circuit we need to record the reading for anode current, voltage across the thyristor, and the holding current. So first, close the switch 1, and then at the left side is the anode current, and the right side is the voltage across the thyristor. The voltage is 12 volt because the circuit is not function yet due to the thyristor is not yet in operation, so the output voltage is same as the input voltage, which is our voltage source. So the anode current is around 1.5 microampere, and the multimeter is at constant, which is 12 volt. So record the value of the anode current and the voltage across the thyristor. Next, we close the switch, and then for the anode current is 756.442 milliampere, and our voltage across the thyristor is 1.065 volt. So next, to determine the holding current, we need to increase the value of variable resistor slowly while observing the multimeter as it reduces. So at some point the thyristor will turning off, and the current indicate just period to turn off the occurring. So when we increase the value of variable resistance, the SCR will turn off. So the reading for the multimeter is our holding current. So we increase the variable resistance. So as we see, the lamp is off, and then our reading is 21.733 milliampere. So that is our holding current. So that's all for the simulation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Azim bin Muhammad FAUZI, and my metric card number is DE1900145. So today I will explain about the activity 3, which is the phase control for the SCR, which is the silicon control rectifier power switch for exercise 2. So here is the completed circuit for the simulation in this multi-sim. I will explain in detail on what is the component that we use in this circuit. So the first one is the 12 volt peak to peak with the frequency of 50 Hz of VAC, and then one one regular resistor which is 470 ohm, and then one variable resistor which is we set it to 10 kilo ohm, and one capacitor which is 330 nanofarad, and then one diode and one SCR. And don't forget to put the virtual lamp with 12 volt. So the purpose of this lab is to monitor the output of Vs, which is the V source, and then the V load, whether the output waveform is vary by the condition of this variable resistor. So there are a few parameters that we needed in this lab, which is the V out and I out DC for the circuit. So we place the multimeter in series here to find the I out, and then the multimeter in parallel here to find the V out. So we will start the simulation of this circuit. So first of all, we set the output, the condition of the variable resistor to 0%, and then we run the circuit. So I will show you the constant output for the oscilloscope, for the output waveform in this oscilloscope, which is connected to the V source. And then, so here is the output waveform. As you can see here is the 12 volt AC. So this is the constant output waveform for the V source. So what we have to see is here at the oscilloscope in this side. As we know, the oscilloscope has two channels, which is channel A and channel B. So for channel A, we connected to the load, and channel B we connected to the V source. So I changed the color for the load, which is to blue color. So it will be easier for us to determine the difference between these two output waveform. So as I mentioned earlier, that I set the condition to 0%, and as you can see here, that here there is the virtual lamp blinking, which means that there is a current flow through here. So we will see the output waveform. So for the red one is the V source, and the blue one is the load. So here is the output waveform for this minimum condition of variable resistor, and this means that there is a current flow through the circuit, which leads to the virtual lamp blinking. And then we determine the output current and output voltage here. As you can see, we stop the circuit, and the output waveform for the minimum value, which is 230.387 milliamp, and the output voltage is the 3.318 volt. And then for this lab, we need to identify three angle, which is the minimum, medium, and max. So for the minimum value, I have determined the value earlier, and then now we proceed to the medium value. So we will proceed with the 45% of condition of variable resistor. So as you can see here, here is the output of virtual lamp. The current is blinking. The virtual lamp is blinking, so it means that there is a current flow through it. So we see the output waveform. The output waveform has slightly different angle from the minimum value. As we can see here, the output waveform is different, which means that from the minimum value, the output waveform is more to the sinusoidal wave, but here there is an angle that we will calculate later. And then here is, which means that the SCR is working at 45% condition of variable resistor, and then we will determine the output current and output voltage here. Here is the output current, and here is the output voltage. So for the last one is the maximum value. Maximum value, as we know, it was 100%. So before we forgot, at 50%, as we can see that the light is not blinking, which means that at 50% and above, the there are no current flowing through the circuit. So at 100%, we will set it to the maximum and we will see the output oscilloscope. Here, as we can see, there is only the output waveform for the V source, and there are no output waveform for the load, which means that there are no current flow through it. So next, we will determine the output current and output voltage. So here is the output current and here is the output voltage. So that's all from me. Thank you.